Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 160 called the intersection of two linked lists. And for this particular challenge, we are using the TypeScript as our language. If you want to use something else other than TypeScript or JavaScript, then go ahead, I encourage you to do so. And for this challenge, given the head of two singly linked lists of the head A and both head B, return the node at which of the two linked lists intersect. If the two linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. And for this node A right here, we have A1, A2, C1, which is the intersection base, and C2, and then finally C3. And for the B right here, we have B1, B2, B3, and then finally they are both intersect at C1. And this is considered the intersection of the list node. And since we have the function of the get intersection node with two parameters that takes two parameters, which the first one, which is the head A and then the head B, it is possible that either a list node or null, and the expected output is in a form of another list node. So we have to return the node to be the answer, which is the C1 right here as the intersection point, and return this as a list node. And we can use two pointers for this approach. And the test case is such there are no cycles anywhere in the entire linked list structure. Okay, so for that, the linked list must retain their original structure after the function return. So for the if we haven't returned the intersection, which is the C1 right here, we have to return all of the C1, C2, and C3 without any mutation of the existing linked list from both lists. So we can just return either list node or null. And for this custom judge, you can read everything. And without further ado, let's solve this out. But before that, for the sample 3 right here, we do take note that there is no intersection between list A and list B, so we will return null right away. And I'm going to use the approach from this example A right here. We are using the two pointer approach that repeats to other lists and check if they are both meeting at the same point is by using this highlighter here. Let's say we are starting from both. On the node A we have 1, and this is another 1 which is on the node B, and the next step, which is denoted by the 2 right here, 2, and then 3 on the node A is on the 8, and this is the A, which is A3, and then 3, and then A4 is placed right here, and the B4 is placed right here. This is the steps that we are taking. For the A4, it is one node, it is one step further from the B4, which is the node 8. The B4 is on the node 8 and the A4 is on the node 4. And for this A5, then this is the B5 that we are currently on. So A5 is placed after the B5, and then after the A5 has been completed iterating, then we need to flip the A pointer to the B pointer. So we are starting from the 1 using the right color. This is the A in the 6 right here, and for the B5 right here, we are on the 6, which is B6, and for the next one, the A is on 7, and the B, after B already been completed iterating, then the B will flip to the node A, starting all over again from the head A. So let me use the green color. Then B is placed right here, and this is 8, B8, and this one is A8, 8, and then 9, and they are both meeting at the same point. So let me redraw this again to make you understand. I'm going to use the right pointers again. Let's say we are iterating this part. They are both on the same node 4, A on the 4, B on the 5. And on the second iteration, they are traversing the A on the 1, B on the 6. And for the next one, A on the 8 and B on the 1. And for the next one, 4 and then 8. The next one, 5 and then 4. After the A has been completed, then it will reiterate over the B, and the B pointer is still on the 5 right here. The next one, since B already been completed, finish iterating all of the B nodes, then it will return back, reiterate over the head A again. Then they are both eventually on the same distance before intersecting to one another. And the next one, they are both on the same distance, and finally they are both meeting at the intersection. So let's code this out by declaring two pointers using the let current A is equals to the head A, that takes the use the parameter of the head A, and also on the second pointer, which is the current B, we can use the head B. And next one, for the place order, we can return null if we don't find anything at the end of the code of the function. And for the next one, we need to check for the edge case if they are both already the same thing on the same node intersection. You can use the current A is already equals to the current B. Then we can simply return the current A. You might want to return current B or current A, it's the same thing. And if it's not, you can use the while loop as long as the current A is not equals to the current B, then we can simply move the current A towards the current A dot next. But if the next node is already null, or the current A is stated as null after declaring the next property, which traversing over the next node, if it is reaching the end of the node, then of course we need to direct the current A to the node B, which is on the head B right here. We can use the ternary operator, check the current A. If the current A is not null, then we can use the current A dot next. If it is null, if the current A is null, then we can use the alternative approach using the else, which is the colon sign right here, and we can redirect the head A to the head B, the current A to the head B. And the same thing also applies on the current B, using the current B. If the current B, as long as it exists, then we can use the current B dot next. And if it's not, we can use the head A if it's reached the end of the node. And we can check as we traverse using the while loop, using the current A is equals to the current B. If it is, then we can return the current A, either the current A or current B. You can do that, but we can, after all of the code completed, we can simply return null to catch the function and ultimately completes the get intersection node function. In case we don't find anything to our favor, let's check the code to see if it works. We have the accepted solution. What happens if we remove this if check right here for the edge case? Let's submit this code, and we have the wrong answer right here, which is on the test case number 38. We have the list A of 1 and list B also not 1, and the output has no intersection, which is stated as null, but the expected output is intersected as node 1, which stated that the node A is on the same node as the node B. They are already intersect with one another on the very first node. So that this is why I am adding the if check right here. If the current A and current B already on the same head, then we can just return the node right away. So let's run the code again to see if it really works. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section. Or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.